Introduction to Experimentation, an overview of the lab activities. Lab objectives. To gain familiarity with some of the measurement tools you will use in the lab this semester. To learn how to measure displacement with a motion sensor and force with a force sensor. To acquire experimental data and be able to present it both statistically and graphically, becoming skilled at the analysis and interpretation of the data. Activity 1. Reaction time. In the first part of the lab, you will generate data by measuring your own reaction time. Your lab partner will then repeat the experiment. Afterwards, you will graph the data on Logger Pro and compare your results. Measurement. You will be using the stopwatch software that measures your reaction time. More specifically, the time interval between the audio cue from your computer speakers and the hitting of your keyboard spacebar. Key questions. How well does your reaction time data align with the normal or Gaussian distribution? Were you and your lab partner's reaction times statistically similar or divergent? Activity 2. The motion sensor. In the second activity, you will familiarize yourself with the motion sensor. Measurement. A motion sensor is a device that continuously emits sound pulses which bounce off an object and detects them when they return to the sensor. By measuring the time interval between the departure and arrival of the pulse, and knowing the speed of sound, the distance to the object can be determined continuously. The motion sensor you will use can measure objects between the range of 0.15 to 8 meters and has a resolution of 1 millimeter. Key questions. How do you measure displacement with a motion sensor? There are limitations associated with any tool of measurement. What is the sensor's field of view? Activity 3. The force sensor. In the last activity, you will familiarize yourself with a force sensor. Measurement. A force sensor is a device that continuously monitors the force exerted on it. There is a metal strip inside the sensor that deforms slightly in response to the force applied. Since the metal's electrical resistance varies as its dimensions change, the electrical signal can be converted to a value for force. The force sensor you will use has a range of 10 newtons and a resolution of 0.01 newtons in low range, and a range of 15 newtons and a resolution of 0.05 newtons in high range. Key questions. How does a force sensor work, and how do you use it for measurement?